So it was found what looks like an intentional VPN backdoor on Android, and we have very good reasons to think it's intentional. I'll dive into this here today, and I'll also show you how to fix it locally, showing my own Android as an example if you want to issue a local fix. Temporary, but it works, so you can keep using your VPN safely. Okay, so let's understand what's going on. I only got notes of this issue because of this Mullvad post today, May 12, and I wrote about Mullvad here on decoding.substack.com. That is my free publication. You can subscribe for free. So go ahead and check other posts on other content that I also published there. I wrote about NVPN, Mullvad VPN as two very good VPN tools. Mullvad VPN I follow on X. They made this post like 5 hours ago reporting about this vulnerability, and this is working to help people get notes of what's going on. And I only discovered this because of Mullvad, so thank you Mullvad, and everybody should keep sharing these things so more people can discover and can issue their own fixes. But it wasn't discovered by Mullvad. It was discovered by Yusuf, this security researcher here that is an expert on Android. He was the one to find the bug, to issue the proof of concept, and to report the vulnerability to Android. And here is when things start getting a bit weird, because he made all the reports as he should do, but as Mullvad reported here, the Android security team closed the report, the bug report, as a won't fix, infeasible. However, Graphene, that is a security-focused Android-based operational system, quickly patched the issue and released the patch already. Okay, so it can be fixed. But Android security team, for some reason, and this is connected to Google, doesn't want to fix it. Why, right? Looks like an intentional backdoor, in my opinion. And things get worse, because when we come here to issuetracker.google.com to look for the vulnerability report, we get an access denied to this issue. So it's hiding in plain sight, which makes everything worse. This works, okay, it's a real exploit, a real bug. The security research has a proof of concept that is open source, it's live on GitHub here, the quick VPN bypass. Everybody can reproduce it if you want, simulating an attacker's app, getting access to the user data and the user IP, even when the user has the always-on VPN plus block connections without VPN turned on that should protect the user from that. I won't get much in the technical details. You can check the official reports here to understand the bug and how and the exploit itself. But basically, it uses a vulnerability that when a quick connection is being closed on Android, and Android has an implementation that allows this quick connection to be closed elegantly, so it gets closed gradually. While this is closing, the app can make certain calls, getting system level permission. Okay, and this allows him to connect directly to the physical Wi-Fi instead of connecting to the Wi-Fi through the VPN tunnel that would masquerade the IP. So they can connect directly to the Wi-Fi that is at the hardware level of the system, and is at the system level, sorry, and get all the data as if there were no VPN connections. This implementation happened on February 2025 on Android, and they reverted it 1 month later in March 2025, but they reverted the reversion back on the same day. It's crazy. So here the security research explain all the layers of the bug, how it's covered it, how it can be used by a malicious app to get the data, and you can get access to that. But the part that matters more to me right now is how to fix it, because I am an Android user as well, and I want to understand how I could fix it. So we will show you now how it can be done. I'm mirroring my Android here. I have a Samsung iPhone, a Samsung smartphone. Sorry. What you will need for that first is, if you use Linux, I don't know what tool you can use on Windows or Mac, but on Linux you use a tool called Android Tools, and you need to find it in your packet manager. Typo here, sorry. Android / tools. I'm using Arch Linux, so I use the pacman package manager. You need to get these tools here installed, and you can then access some developer level options and debug your Android on your Linux, and this is what you need to issue this fix. So this at your host and computer level, so you can debug. But you can also access that via your phone. For that, you need to enable the developer options. It doesn't come enabled by default. You need to turn it on. How you do that? You go to About Phone. I won't click here because it will show some information I don't want to show about myself. But you go to About Phone, and you go to software information. If you're using Samsung, other devices might have a different path, but it's something like that. And you look for the build number of your operational system, of your Android. You go to the build number and you click 7 times on top of the build number field. 1, 2, 3, 4, 5, 6, 7. And once you do that, it will enable these developer options on your settings. If you're using Samsung, again, I don't know about other devices, you also need to disable your auto blocker that comes by default as a security and privacy feature. You go here, auto blocker, disable it. Then you go to developer options. You look for debugging, and you will enable USB debugging. Once you enabled it, you will get an USB cable, will connect your smartphone to your computer via this cable, will trust the device, will allow access from the computer, and it will allow you to execute some codes on your terminal that will affect your device. So let's check here what codes we need to do. I already issued these fixes, so will just show you. But the fix is basically exists because the security research is a local mitigation. They found this flag in device config named tethering, where you can disable this elegantly quick closing connection. So you call these functions here and use the flag -1 that will disable this function, close quick connection. And this is what you need to disable to issue the patch locally, because when it's enabled, either at the build's default unset or force enabled with the flag 1, this is where the vulnerability lies and where it can be exploited. So you need to disable it. To disable it, we will execute the code here using your Android tools. So ADB, that is Android debugger something, I don't remember what the B means, but it's part of the Android tools stack. You will use shell as the script language. You access the device config, and you will put the new configuration there using the tethering function and disabling the close quick connection. You will press enter here. It will apply the config, but for that to be seen in your device, you need to ADB reboot. When you press enter, your device will restart, will reboot, and the new configuration will be in place now. How can you check if it's working for you? So you need to check if the close quick connection is disabled. So you can use this verification here, also suggested by the researcher, ADB, shell, and you use the code here, dumps connectivity, and you look for, you grab for close quick. When you do that, if it returns false, because it's a boolean, if it returns false, then close quick connection is disabled. If it returns true, is because the new configuration didn't apply. You can check back and revert it by using the same here, this same code, but changing the flag to 1. It's a force enabled, as he showed here. And when you use this ADB shell dumps connectivity grep, you will get the true boolean flag. Okay. This is it basically. You need to reboot every time, but this is it basically. The problem here is that when you update your Android system by Google's releases, by Google's updates, the configuration will be back to the build's default, and it might be enabled. So you need to come here and do everything again. Okay. Another caveat here is that it disables the graceful quick teardown for every app on the device, not just for the attackers. He believes the cost is small. Me too. I prefer to use my VPN safely without needing to worry that an app wants to see my IP when I don't want them to see the IP. But the quick connections will just time out on the server side instead of being closed gracefully, elegantly, like Google's enabled implementation has enabled. Okay, so that's it mostly. Hope this was informative. Hope you learned something today. You can follow me on X, where I also publish related things at Vini Barbosa BR, and subscribe to decoding.substack.com for free, that I also publish related material there. Thank you very much for watching me, and see ya.